Okay, in this video, we are going to sketch a 3-leaf rose, and this is a polar curve, r equals sine 3 theta, and we're going to go ahead and sketch the graph of that. Well, what we're first going to do is sketch the graph of r equals sine 3 theta along a theta r axis, or plane, I should say. Okay, the period is equal to 2 pi because it's sine, and divided by 3 because that is the coefficient of theta. The period divided by 4 is found by multiplying the period by 1/4, and that will give us pi over 6. I'm going to ignore the idea, or I'm going to ignore making the x and y, or the r and theta axis to scale. So I'm going to start at 0, and the next key point will come at pi over 6. In fact, let's just put those in later. Okay, let's just jump in for the fun part. Let's go ahead and put in the graph of sine. And the key points I'll label later. So the graph of sine looks like this. It's a wave. I have the graph paper to help me out. But I don't want the graph paper to make it sort of stop me from getting anything done really well. What I want to do is I'm going to do 3 cycles. So the period, I'm going to start labeling it a little bit. The period is 2/3 pi. Now, if I had another period, 2/3 plus 2/3 makes 4/3 pi, so I've done 2 cycles. And if I do one more cycle, I'll see that that takes me up to 6/3, which is 2 pi. And I can also now go ahead and, well, let me put these numbers here. This is -1 and 1. I can also go ahead and put the quarter period. So I have 0. Then comes 1/6 pi. 2/6 pi, which is pi over 3, and then what is it? 2/6 which is pi over 2. Now we know that if I go from 0 to 2/3 and divide that by 2, I get pi over 3. That's another way of seeing this. So you get 1/6, 2/6, 3/6, 4/6, 5/6 pi, 6/6, which is pi, 7/6 pi, 8/6, 4/3 pi, 9/6, which is 3/2 pi, 9/6, 10/6, which is 5/3 pi, 11/6, 12/6, which is 2 pi. Okay, right, there we go. So that is r equals sine 3 theta, but now I'm going to go with this down here, and sometimes I worry, am I have enough room? Okay. Now, I am going to make dotted lines where r is 0, which are the intercepts along the horizontal. So r is 0 at 0, theta 0, r 0. At pi over 3, now when I do pi over 3, this is going to be roughly done because the graph paper doesn't really, it doesn't allow me to get this exactly right. So I'm going to think it's around like that. And actually, it ends up going to the other side. Let me do that right now to get it straight. And then we see there's 2/3 pi next. Oh, wow. Okay, then there's 4/3 pi. And then 5/3 pi. Oh, and by the way, there's pi. Don't forget that good one. Okay. And then 6/3 is 2/3. There's 2 pi. Okay, Then we do these loops, and that's where I think it starts getting super fun. Okay, this top loop starts when theta is 0, and then at pi over 6 it goes up to 1, and then it goes back to 0 pi over 3. I am going to try to make these loops all the same. These are petals. But then we have another petal here that's I don't know. Have good colors here. This other petal is between pi over 3 and 2/3 pi, but notice r is equal to -1 right there, so it's going to come up the other side. It's hard for me to get the lengths of these the same because they're not really on the same, along the same, they don't have a scale that's the same. It's easy to do. Okay, now back to this pink color. Between 2/3 pi and pi, I'm going to get this next one. Sort of close in size to the others. All right. Then I'm going to get from pi to 4/3 pi. This other loop, see, it's coming around. Hold on. I think I did that one wrong. Okay, sorry. Between 4/3, all right, between pi and 4/3 pi, I get a loop. But see what happens. I did do that wrong. I'm sorry. Between pi and 4/3 pi, I get r is -1 again. See here, r is 1. So when r is -1, this part here between, I'm going to erase all that, but between pi and 4/3 pi, all those points get reflected to the other side. That curve is going to be reflected to the other side. So it's actually going to come around again. It's going to retrace. And the same thing happens between 4/3 and 5/3. Now r is 1 over here. And so I'm going to retrace again. And then between 5/3 and 2 pi, it's going to go over this once again on the other side. So now I'm going to see about coming with a really, let's get a good color. Let's get orange. So I come along here, and it makes a nice smooth curve. It doesn't have any sharp edges. And that is r equals sine 3 theta. Okay, now, what can I say here is that, well, now let me just clean up this one piece here. I feel like I should label this as 1 away. So I put a little mark there. But what can we say about this? Well, this number here is obviously 3. And I'm going to say this is n equals 3, which is an odd number. And when you have an odd number there for these petals, not for all curves, but for these rose type figures, if that number is odd, then I'm going to have that many leaves. So if it's an odd number, like 3 is, as we know, then that's 3 leaves. If it's an even number, like 2 is an even number. If it had been 2 there, then it would be 2 times 2 is 4 leaves. All right, so that does that.